Imagine waking up in a country where the rainy season can slice entire neighborhoods off from the rest of the city. Where a single storm can turn a busy road into a muddy trench, stranding families, stalling businesses, and cutting farmers away from markets. Now imagine the government not only promising to fix it, but actually mobilizing a new, faster, cheaper way to build roads by blending modern recycling machines with community power and simple, smart engineering. That is the story unfolding in Burkina Faso under Captain Ibrahim Traoré, and the approach is surprising experts around the world. Here is the bold idea. Instead of waiting for giant contracts, endless imports, and slow-moving asphalt convoys, Burkina Faso is moving toward an approach that flips the usual order. Drain the water first. Reinforce the weak spots with soil-filled bags that lock together like bricks. Recycle the broken road you already have to create a strong new base. Then cap it with a tough, water-shedding surface. It is not flashy. It is not about buying everything new. It is about building smarter with what you have, faster than people think is possible, and doing it in a way that local crews can learn, own, and keep maintaining. Let's start with the reason this matters. Burkina Faso's climate gives it a concentrated rainy season, and when those storms hit, unpaved and poorly drained roads fail fast. Floodwater looks for the weakest path. If side drains are too shallow or clogged, water jumps the curb, eats at the shoulders, and punches potholes straight through a roadbed. Urban growth adds hard surfaces that shed water even faster. The result is a transportation system that can feel strong in the dry months and suddenly fragile once the clouds open. When roads go down, food prices climb, health emergencies become riskier, and small businesses lose time and money they cannot easily replace. Every day a road stays closed has real human costs. Now, what is different about the method taking shape? Think of it as a four-part playbook. First, water management comes before asphalt. Crews walk a road and mark where water enters and where it gets trapped. They cut and shape side drains so they actually carry water away. They add culverts at the low points, not just where it is convenient for a machine, but where gravity demands it. In the worst trouble spots, they carve small retention basins, the kind that take the punch out of a storm by holding water for a while and releasing it once the peak has passed. When you build the plumbing first, the road on top has a chance to survive. Second, the subgrade gets reinforced at its weakest links. This is where the soil bag approach comes in. It is called dunu in parts of East and West Africa. The idea is disarmingly simple. You fill sturdy bags with the local soil or gravel, tie them shut, and lay them tightly in courses like bricks. You compact them until they become a single, dense block. You use them to bridge soft spots, firm up shoulders, build low retaining edges, and even create small check dams inside drains to slow water just enough to drop sediment. It sounds humble, but it transforms a loose base into a reinforced platform that resists rutting. Because it uses local material and hand tools alongside compactors, neighborhood teams can be trained quickly, and the skill stays in the community. When a dip starts to form months later, the same team knows exactly how to open, replace, and recompact the bad patch. Third, the existing damaged road is not waste. It is raw material. Mobile recycling machines grind the old surface together with the underlying layers and blend it with a small dose of stabilizer, like cement or lime, and just enough water. Crews spread and compact that blend to form a strong, uniform base. Engineers call this in-place recycling or full-depth reclamation. The benefit is big. You avoid hauling thousands of tons of fresh aggregate over long distances. You save fuel, time, and money. You also end up with a base that is more uniform than a patchwork of trucked-in layers. Because the process happens right there on the road, communities see progress every day, not just a caravan of trucks passing through. Fourth, the cap is chosen to fit the traffic and the budget. On roads that carry lighter vehicles and motorcycles, a double-chip seal or auto seal can be enough. It is a tough, stone-rich surface bound with bitumen that sheds water and protects the base. On heavier segments or connectors near markets, crews can lay a thin asphalt layer over the recycled base. The point is not to insist on one expensive finish everywhere. It is to match each segment to what it truly needs, so more kilometers can be upgraded sooner, with less waste. This is not theory on a chalkboard. The building blocks are already in motion. Burkina Faso has trained local engineers and technicians in low-cost reinforcement methods that use bags, proper compaction, and quality control tests that can be done in the field. The administration has also delivered fleets of machines, including recyclers, graders, compactors, and mixers, to accelerate road and drainage works and push maintenance down to the neighborhood level. On top of that, a national push has begun to clear drains and build new ones in secondary cities, because a road without drainage is a short-term promise. Now picture a typical street on the edge of Ouagadougou after a hard storm. Puddles sit where the road dips. Side drains are half full of silt. The surface is a mosaic of patched potholes that gives way to mud after every heavy rain. Under the new playbook, the crew does not start by spreading fresh gravel. They start with a stake and a string. They trace the fall of the land and mark the path for water to leave the road. They dig and shape the drain, compact the sides, and line the most vulnerable sections with soil bag walls that resist collapse. They set a small culvert at the lowest crossing and pack the entry and exit with well-compacted bags to prevent scour. Only then do they turn to the roadbed. A recycling machine chews up the broken surface and mixes it with the foundation beneath. A crew spreads the blend to a design thickness and checks it with a simple gauge and a handheld penetrometer or a dynamic cone test. Moisture is adjusted with a light spray so compaction hits the sweet spot. Rollers work in passes until the base behaves like a single, dense slab. That same day, the crew sprays binder and spreads the first layer of stone for a chip seal, then rolls it in. Once it sets, they repeat for a second course. Traffic can return sooner than most people expect, and the road will feel firm underfoot, even after the next storm, because water now has an exit and the base is no longer a patchwork of weak and strong spots. People often ask, how does this really compare on cost and speed? Because recycling reuses what is already there, hauling and quarrying. Because soil bag reinforcement targets only the weak locations, you focus labor and materials exactly where they pay the biggest dividends. Because the finish layer is tailored to need, you avoid overspending on light-duty streets and concentrate the heavier surfaces on the sections that truly need them. The combined effect is that more kilometers can be treated for the same budget, and the work moves in a steady line rather than stalling while waiting for imports. Of course, any method has limits. Recycled bases still need correct moisture and proper compaction. Drainage must be kept clear, which means a real maintenance plan and community pride, not a one-off cleanup. Cement or lime must be available in stable quantities. Security along long rural corridors must be managed so crews can work safely. And there must be enough field testing gear and trained hands to keep quality consistent. None of these are impossible. They simply require the same seriousness that went into launching the program. What makes this moment different is the scale of intent. The leadership has not only talked about adding machines and training. It has publicly set targets that would have sounded unrealistic in the past and has begun work to back them up. You do not purchase hundreds of graders, compactors, mixers, and recycling units to let them sit. You put them into a pipeline. You establish standard methods so every crew builds the same way. You keep the focus on drainage first, reinforcement second, recycling third, finish last, and you hold that sequence across cities, towns, and market roads. That is how ambitious numbers become lived reality. Let's get practical. If you were running one of these crews, your day would run like this. You arrive at a marked segment. The drainage team cuts the outflow channel and shapes the side drains. The reinforcement team lays soil bags in the soft shoulder and at any spots that have shown rutting in past seasons. The recycling team follows, milling and blending the old surface with the underlying layer, then spreading and compacting to specification. The surfacing team seals and stones the top. The quality team documents compaction passes, spot checks moisture, and records density and strength readings on a simple field sheet. At the end of the day, the road sheds water from the crown to the drains. The next morning, the line moves on. Now think about the ripple effects. Farmers reach buyers even during the rains. Schoolchildren are not wading through standing water and mud. Ambulances move faster. Bus routes become predictable. Small shops on the edge of the city can stock supplies because delivery trucks no longer refuse to enter their neighborhoods for weeks at a time. The boring truth about development is that nothing sets growth free like reliable, all-weather access. When a country goes from a patchwork of seasonal tracks to a network of durable corridors and streets, livelihoods stabilize and then climb. The method is also resilient. When storms intensify, drainage-first design keeps roads in service longer. When materials are expensive, recycling preserves budgets. When unemployment is high, soil bag work and routine drain clearing create real jobs that matter, right where people live. And because the skill is teachable, it spreads. A woman who starts by filling bags on week 1 can be checking compaction by week 4 and leading a drainage crew by the end of the season. Skeptics will say this cannot scale. They are right to demand evidence. That is why documentation and transparency are essential. Publish the segment lists. Show before and after photos. Share how many drains were cleared, how many culverts installed, how many weak spots reinforced, and how many kilometers recycled and sealed. Track maintenance response times when a pothole reappears. Set public standards, and when a segment fails, say why and fix it fast. The fastest way to build trust is to show your homework. There is also a role for universities and technical institutes. Students can map flood hotspots, monitor how different soil bag layouts perform, and test recycled base mixes under real traffic. Local labs can refine the stabilizer doses that work best with the region's lateritic soils. Over time, that know-how becomes an export. Other countries start asking how it was done, and the answer is not a foreign contractor's playbook. It is a Burkinabe method, trained and proven at home. So why does the world care? Because most of the planet's road network is not made of wide, multi-lane highways. It is the small, local, everyday roads that decide whether a mother reaches a clinic after a storm, whether a farmer's harvest rots before it sells, whether a student reaches class. If a landlocked Sahelian country can pioneer a new delivery model by mixing smart drainage, community reinforcement, road recycling, and right-sized surfacing, it becomes a template that cities and towns across the global south can copy and adapt. The result is not only stronger roads. It is stronger economies and stronger communities. If you have watched this far, you can feel the momentum. You can also sense the challenge. The rains will keep coming. The budget will always feel tight. But the method you have seen today turns those constraints into design choices. Drain first. Reinforce the weak. Recycle what you have. Cap it to match the load. Maintain it together. That is how Burkina Faso can move from promises to proof, and that is why this story is bigger than one country. Now I want to hear from you. If your city adopted this approach, which piece would you insist on first? Drainage, soil bag reinforcement, recycling, or the surface cap? Would you volunteer for a weekend to help clear drains on your street if you knew it would keep your block passable through the next storm? Which part of the method do you think will be the hardest to keep consistent at scale? Quality control, material supply, or maintenance? If you live in a place with heavy rains, what has actually worked on your roads, and what has failed? Do you believe a community-driven model can build better roads faster than traditional top-down contracts, or should it always be a mix of both? Before we wrap, a quick ask. If you found this breakdown useful, subscribe to the channel so you do not miss future deep dives. Like the video to help more people discover it. Drop a comment with your take on the method, your local road story, or a question you want answered in an upcoming episode. Share this with someone who still thinks the only way to build a road is the most expensive way. Your engagement tells the algorithm that this kind of nuanced, practical content is worth spreading. Thank you for watching AfriPol Lens. See you in the next one.